All right, we use the intermediate value theorem to tell ourselves when a function is increasing or decreasing, because if you are a differentiable function, your derivative is positive, and that means your original function is increasing. And if your first derivative is negative, then that means your original function is decreasing. And we know how to test whether or not a function is positive or negative by using a sign chart, right? It's only allowed to change from positives to negatives if you give it a 0, or if you have a discontinuity, right? So if we're testing for the intervals over which a function is increasing or decreasing, that should scream to you first derivative, right? Is the first derivative positive? Is the first derivative negative? So let's copy down the function and rewrite it as a power. This is going to be 1 minus x to the 1/3. Therefore, the derivative is equal to 1/3 1 minus x to the minus 2/3 times the derivative of 1 minus x, that's minus 1. Our derivative is then minus 1 over 3 times the cubed root of 1 minus x squared. Okay. So this derivative is only allowed to change from positive to negative at zeros or discontinuities. When is that function going to be 0? Never. When is this function going to not exist? Well, what is going to make me divide by 0? So what's going to give me a 0 inside here when x is equal to 1? So that's the only place that we have to check. There's x is equal to 1. Here's the derivative. Here's the original function. And we need some test points. 0 is easy to plug in. And let's try 2. So if you plug 0 into the derivative, right, because whether or not the derivative is positive or negative is going to tell you about the original function increasing or decreasing. So if we plug in 0 into the derivative, you get minus 1 over 3 times the cubed root. 1 minus 0 is 1. 1 squared is 1. The cubed root of 1 is 1. This is minus 1/3. It's negative. So that means that your original function is decreasing, right? The slopes of those tangent lines are sloped downwards. Now let's look at 2. F prime at 2 is minus 1 over 3 times the cubed root. 1 minus 2 is minus 1. Minus 1 squared is 1. Cubed root of 1. Oh, well, we get the same thing. Negative. Right? Again, just because you can change sign doesn't mean you have to. Our original function is also decreasing there. So let's look at this graph and see if we can make sense of it. We just told ourselves that the original function is decreasing everywhere, and we see that. Right? We're decreasing there, we're decreasing really fast there, and then we kind of slow down, but we're still decreasing. In fact, at that point, x is equal to 1, our derivative fails to exist, right? Think about those tangent lines. What are the slopes of the tangent lines at this point? Infinity. Infinity is not a real number. Your tangent line does not exist there, which is why you had that discontinuity in the definition of your derivative.